Hi everybody, welcome back to Sugar Math Practice Lab, Learning Through Practicing. Okay, in today's video, we will continue our unit in the limits, continuity, and the differentiability. And today we're going to start our practice set number 4. In this practice set number 4, we're going to talk about the intermediate value theory and where we applied it. What is the intermediate value theory and where we apply it? Okay, so here we have 4 problems here, and which apply the intermediate value theory to help us to find the roots. And that's one of the applications for the intermediate value theory, so can be used. Okay, as always, and I strongly encourage you to pause the video right now and get the pencil and the paper out and try to do some of the problems by yourself first. And so you can get an idea how to do it. And when you get stuck, and then, after you finish, and then resume back and we can check the answers. All right, so if you like this video, don't forget to subscribe to my channel. And also, if you have any questions, feel free to send me a comment. All right. And so now you can pause your video and try to work some of the problems. And I'm going to go to the whiteboard and get a whiteboard ready, and we can work on those problems. Okay. Hi, I'm back, and I hope you got the chance to practice some of the problems. And I have in the practice set number 4. As always, before we start, let's do a very quick review. What is the intermediate value series here, right? So here I already put on the board so can save some time. So basically they tell you, suppose that f of x is a continuous function of closed interval a and b, and let n be any numbers between the fa and the b when fa is not equal to f of b, then there exists a number c in a and in this interval a and b such that f of c equal to n. You say, what does that means, right? So, like a lot of time when you put the math theory in the wording, is kind of like difficult to understand. So now let's take a look. What does this mean graphically? And then you will say, oh, let's make sense here, right? So let me see here. Okay. So, all right. So now let's see, what is this? I have A's here. I have B's here. All right. So I have a functions here. So this function is a continuous functions between A and B. So I know this is what? This is my f of A. And this is my f of B. Okay. So this theory, if you look at the graph, it's really kind of makes sense here, right? So they said here, now if you have any numbers, so make sure this is a continuous, right? And if you have any numbers n, right? So if you have any numbers n's here, let's say that here, right? So this is my number n's here. And then what is this theory tell you? They say because of this is a continuous, if you have any numbers n's here, you will have, you'll be able to, here, like in here. That means you'll be able to find a value c in between, inside this interval, and will give you f of c equal to n. That's kind of the trivials, right? Because that means, for any n's here, so how about, I have another n's here, right? So if I have another n's here, right? So then based on the intermediate value theory, that means, so in here, you can find So you will find a C here. So this is a C. So you can find another C's here and another C's here, right? So it's a C1, C2, C3. So you can find at least one C. So in this case, you can find 3 different C, but all these C's inside these intervals, and it will give you these numbers, right? So that's what is the graphic meaning about the intermediate value theory. And like I said, it's kind of like makes sense, kind of a common sense, right? So if you give me a numbers ends here, I will be able to find values inside here, right? And then such that f of c equal to m. Okay, so that's basically the brief review about the intermediate value theories here. So now let's take a look at our practice to see how I'm going to use this to find the roots. Okay, so like if I have a function f of x is equal to x4 plus x minus 3. Okay, so in the interval 1, 2, right? So I want to find the roots. That means what is roots means, right? So the roots means here, that means you have some value x4 plus x minus 3 equal to 0, right? So now let's take a look at the intermediate value theories here. The first, right? So the f of x here is x4 plus x minus 3. What type of the function this one is? This is a polynomial. So I know the polynomial is a continuous function that satisfies the intermediate value theories here. And now let's take a look. What is the f of 1 in this interval? F of the 1, if you plug the 1 in here, you will have 1 to the 4th plus 1 minus 3. You get a negative 2. All right. Now let's take a look at f of 2, and another end, f of 2 will be 2 to the 4th plus 2 minus 3, and it will be what? Will be 15. So you see here, right? So you see one is negative number, and the other one is a positive number. So that means for these functions here, I don't know exactly what is this function looks like, but what is this function tell you here? You know, I start out with the negative numbers here, right? I start out with a negative number because this function is continuous. So this function could go this. When it comes to the 2, it's a positive number. So that means I know by the intermediate value series here, now here's zeros, right? So I know I can find a roots in this, in this intervals, right? Okay, so I don't, how to solve it is a different stories, right? So I know because of the intermediate value, so I know due to intermediate value series, okay? Oh, I think instead of, I think the people call this intermediate value, say IVT. Now I know, so I know the f of x is here, the x4 plus x minus 3 equal to 0. And so that means there exists. So there is number C such that, okay, so such that f of the C equal to 0. So, okay, so there is a root. So we know there is a root of the equations f of x equal to x4 plus x minus 3 inside the interval 1, 2. Right? It's kind of like a very common sense. If you start with negative and this is a continuous and then end out with a positive, they have to pass in the zeros, right? So that's what is our definition about the roots here. Okay, now let's take a look at the part B here. It's the same way. So as you can see, those problems are pretty straightforward. So this is a natural log x is equal to x minus the square root of x, right? And then the interval I'm interested in is 2 and 3. So you can move these ones here. So natural log x is minus x plus square root of x equal to zeros, right? So that means I'm going to find the function. So this is natural log x minus x plus square root of function x. So we know f of x is continuous. Why is it continuous? Because, why? Because I have, why is it continuous? Because I have a natural log function, polynomial, and a root function. All these three are continuous. So when you do the plus minus your continuous functions, they still will be a continuous. It's because the log is continuous. X, we can call this is a polynomial, is continuous. The square roots, this is a what? This is root function, is continuous. So when you combine those continuous functions, it's a continuous. So now let's take a look at f of 2. So f of 2 will be natural log 2 minus 2 plus the square root of the 2, right? Okay, so this ones here will give me approximately the value will be 0.107. Now let's take a look at f of 3 here. The f of 3, it will be natural log 3 minus 3 plus the square root of 3, right? So these ones here will give you approximate number is negative 0.169 here. So because this is just like we did here, I don't know what is this function exactly looks like. This is 2 and 3, but this function start with 2 is some positive number, so it could do something, but when it come to the 3, it's negative numbers, right? So that means I know it's going to what? It has to going to pass the x-axis, right? So that's what is the root. So I know I can find one c, right? So could be 2c or 3c's, but I know I can find one. So we know this one's here. So we know there is what? There is a c in the interval 2, 3, such that f of the c will be equal to 0. So there is what? There is a root of the equation natural log x minus x plus x square root of x equal to 0. We should have said at least one root, right? Could it be two roots because it's continuous. We don't know what its graph looks like. So if they touch the x-axis twice, that means you're going to have two roots here. So it's pretty straightforward, right? So let's take a look at a couple others, and then I think you will be very familiar with that, and I think you will feel very comfortable to do those type of the problem by using the intermediate value theory. Okay, so this is the EX is equal to 3 minus 2x here at the 0, 1, right? Okay, so the same way I can say it's minus 3 plus 2x equal to x equal to 0. So I can set this one is EX minus 3 plus 2x, right? So I know f of x is what? F of x is a continuous. Why is it continuous here? Because EX is exponential, and this ones here you can say is linear. So, the polynomial doesn't matter because I know the exponential is continuous, right? Then also I know the linear function is continuous. So when you have two continuous functions together, it is a continuous. So that's why I can concluded f of x is a continuous in these intervals, right? In these intervals here. Okay, now the same way, let's try see f of 0. F of 0 is what? Will be e0 minus 3 plus 2x, 2 zeros, right? Okay, so this is 2 zeros, so it's a negative 2. Okay, so the same way I have f of 1. F of 1 is e1 minus 3 plus 2, right? So what is this one's here? So this is equal to e minus 1. So I think approximately to 1.72. So still, as you can see, 1 is negative, 1 is positive, and this is a continue. So what happens here? It has to pass, right? So we can say there exists, so there is a number C, right? So at least one number C inside 0, 1, such that f of C equal to what? Equal to zeros, right? So I know f of x, right? There is x is ex minus 3 plus 2x, right? There is a root. So there is root in the interval 1, 0, 1. Right? Okay, so last province here. So the last province here, sine x is equal to x squared minus x at the interval I'm interested in is 1, 2 here. So you can do the same way. So we have said f of x is equal to sine x minus x squared plus x, right? So I know this is continuous. Why? Because the trig function is continuous and this part is the polynomial. So I can conclude, I can say f of x is continuous. Let's satisfy the first condition about the intermediate series, right? So it's continuous at 1, 2. And so why is it continuous? Because the trig function is continuous, right? So trig function is a continuous functions, and the polynomial is continuous. So when you combine the two continuous functions, it is continuous. Then we can just apply the intermediate value theorem. Let's see what happened to f of the 1. So f of 1 is sine 1 minus 1 squared plus 1. So the sine 1 is close to, so this is the sine 1, that's right. So this cancels, so it's a sine 1. Sine 1 is approximately to the value. If you put into your calculator, don't forget this is radians, right? So it's 0.84. Then the f of 2 here, this will be sine 2 minus 2 to the square plus 2. So it will be close to, if you put into the calculator, so negative 1.09. Hey, so as you can see here, the same way, 1 is positive, 1 is negative, and this is a continuous function. So we know, so there is a number C, right? Inside this interval, 1, 2, such that f of the C is equal to zeros, right? So I know that f of x, this one's here is sine x minus x squared plus x. But, so this one has a root in the interval. Zero, 1. And that's it, right? So you can see this topic is really pretty easy, and it's kind of like makes sense when you look at the graph. It's kind of like you say, yeah, that's obvious, right? And one of the applications here is can help us to identify whether these functions have a root in a certain interval you are interested. Okay, so don't forget, try to find some other problems. So it's practicing. That will make you getting better and better and better in the math. And very glad to be able to talk to you about the intermediate value theory. And then our next video, we're going to start to try to use the limit definition to derive the derivative, to see how do we derive the derivatives by using the limit definitions. Then the last video in this unit, we're going to talk about when is the differentiability is not exist for our functions. Okay, that will be gradually we finally get into the derivative part and formally start the calculus. All right. So the nice to talk to you again, and hope you will watch this video. If you like the video, don't forget feel free to subscribe it. Or if you still have some concept not clear, send me put a comment and I will answer your questions here. Nice to talk to you. Have a nice day. Okay. Bye.